Hello friends, welcome to Tech by Gaurav K. I hope you all doing great. I hope you enjoyed the last video regarding what is DevOps, and I hope it made you understand why it is being used so aggressively in all the organizations in the current scenario, and how it helps the business deliver applications in a faster way, in a more efficient way to the customers, and keep them happy. Today we are going to discuss the next step in the journey of DevOps and a new kind of avatar of DevOps, which is known as DevSecOps, and why it is so important in the current scenario, and how it brings different aspects to the DevOps process that we had discussed earlier. So let's do a deep dive into this today and try to understand why do we need to know about DevSecOps and how it further enhances the efficiency and the reliability of the application that is delivered by any organization to their customers. So, if you have watched the last video and if you are working in the DevOps domain, you understand DevOps is a culture, it is a process or a set of processes which helps you manage the application lifecycle and keep it running in a fast and efficient way. So, if we try to do a little deep dive into this now, so let's try to just break down these three terms. So if we say development, as we had discussed last time, it is it is what dev means, and security is what sec means. And as we discussed earlier, ops refers to operations. So to be true, we are in a way talking about three different teams here. So this is a team, and so is security, and so is operations. So in a way, when we say DevSecOps, we are trying to say that we are combining these three teams together. So this is kind of a gist of what DevSecOps means. Let's do a deep dive into this and further understand why it is important to do that. So if we go back a little into the DevOps process, so what we talked about was we have a plan stage, we have a code stage, we have a build stage, we have a test stage, and then we further have a release stage, and then we have the deploy stage. We have two more stages, the operate and the monitor. So all these 8 stages combined together kind of form the entire DevOps pipeline or process that our application flows through, right? It flows through the entire process, and at the end, we have an application, a working application as the end product. So This definitely helps us in getting to the application in a fast, efficient, and quick way. But at the end, if you see, there is another process which is added, and that is security testing, which we didn't discuss in the DevOps process. So security testing is something which, when the application is live, this is more of a traditional way that has been working. This is the way it has been working traditionally. So the application is now handed over to the app security testing team, and they actually take somewhere around few days to maybe few weeks or months even. So that is something which the security team needs in order to validate the functionality of the application and make sure that the application is secure to use. But in this entire process, the application, this entire pipeline that we see here, the DevOps pipeline, it never stops. It keeps running. And with this, we have kind of a new version of the application, like the V1 version, V2 version, and V3 version. And since the security testing takes few days to weeks and months, we might have reached the V3 stage by that time. And then the security team comes back with its analysis and tells us that we have got certain critical vulnerabilities that we need to look into, certain threats that have been identified. And this review goes back to the very initial stage of the process, that is the code stage. And this is when the entire flow kind of stalls. So in the code stage, we have different types of code. We have the infra code, we have the, let me try to make it a little better in terms of the view. So in this stage, we have the infra code, we have the application code, we have the testing code. Okay. So now the vulnerabilities are identified by the security team, and they are further looking into the code, into the infra code, the application code, and the testing code is actually used for testing. So primary focus is on infra and application. And then again, we go to the build process. We build the software and then test it, then release it, and deploy it into different environments like QA, and then move it to UAT, performance, pre-production, and then production. And then we make the application go live again. And then again, the security team comes into picture and this process goes on. So now you see there is a lot of friction here, right? Friction in the sense that DevOps is certainly helping deliver the application to the customer, and it's making life easy for the customer and it's making the customer happy. But what if the security team comes back to the application team and tells them that your application is not reliable in terms of security? It is lacking certain aspects which make it very vulnerable to the cyber threats, the current security posture is not ready for the production. In that case, your customer will be happy with the delivery speed, but not with the delivery quality or the reliability in terms of security. So, this, in a way, hindsight comes back to you, and you have to stop everything here. All these versions kind of get stopped. You need to work on it and rework, keep getting this done based on the feedback from security. So, how can this be solved and be made more agile? So, for that to happen, we need to bring the security team more closer to the entire DevOps process. This is kind of known as the shift left approach. So, in this, we have to make the security part of the DevOps process, and that's what we talk about DevSecOps. So, we add security in the mix. So, this is the core fundamental reason why we are talking about DevSecOps today. And how do we actually move it to the left? We'll discuss that. But there are other reasons as well. So, as we discussed last time, we saw that one of the primary reasons for DevOps to come into picture was cloud. So, cloud has brought agility in terms of infrastructure scalability and readiness, which is the best part. But it has also increased the attack surface. So, to be to be precise, what cloud has done is it has made you put the data and your services outside your premises, right? So you are hosting it outside your premises. So now you need to ensure that you are taking care of the security of your data and services as well. So that, in a way, increases the attack surface for your services and data. So that's the second reason I would say. So this entire delay, the friction that we get as a result of this being in the end is one reason. The second reason is the increase in attack surface since we are using cloud now. Third and important reason in the today's scenario is the use of microservices architecture. So to be very simple and in layman terms, microservices architecture is doing what is it's actually dividing your application into multiple components. You have an application A, and when you use microservices, you get multiple such application components which run your application, be it like B, C, D, E, F. Suppose you have five further components, and these are individual microservices which are running your application. They are interacting with each other in a way that you have designed it, and they are working as a single application in unison. So in a sense, this is what your application A is with microservices. And along with the different components of the service, you have different services which are attached to it, like database, like different networking components, different API management services, different components like WAF and others. And you also have many third-party services that you're using. So if you see from a single application to moving to microservices, your entire attack surface is further increased. So there is a jump in the attack surface with using microservices as well. So it's highlighting the point that cloud did as well. And if we move to the fourth point, I think it's hinting towards the same thing, and it's the container infrastructure that is being aggressively used. With container, you're using like services like Docker, Kubernetes, orchestration. So, so these are actually further enhancing or increasing the surface area for attack. How do they do that? So with containers, we use images, and with images, you can have inherent vulnerabilities. So these images need to be scanned and they need to be validated for any inherent vulnerabilities or any issues or corruption that they might bring into your infrastructure. So this further increases the need for a new version of security, or rather a new approach to security that we need to bring. So we cannot say that we have built a secure setup one time, security as a deliverable or tool one time, and that's it. Our environment is secure, and there is a team who is taking care of it. We cannot say that anymore. Why? Because everything is moving at a fast pace. If you see with DevOps, the application delivery, the versions that we see is being delivered at a very fast pace, and your application is getting evolved as per the customer's requirement in a fast way. And you cannot just say that once you put the security testing in, you're done. So you have to evolve it. And same applies for cloud setup as well, because cloud is changing at a very fast pace. You see so many services in different clouds providers day in, day out, and it's pretty flexible. And with this flexibility, it brings in the need to integrate your security services in a evolving way, along with microservices usage or container usage. And in future, you will have many other components. Means there are still other components which I have not described here, but this is kind of giving you the basic understanding of the scope of security attack surface that has increased. So we need to get security into the system. Like we know we don't need it as a one-time solution. It's not going to work. What we need is security should be part of the entire process. So we should make this entire process secure. So how do we do that? So when we set up the DevOps process, we have these stages as we discussed. What we need to do is we need to bring in the security components at each stage. So it's like we are integrating security at each level. So when we set up the code repositories for infrastructure, for applications, for testing, we can use features like pre-commit hooks, which are like IDE plugins. which in a way help the developers or the operations team who is writing the infrastructure code get to know about the known vulnerabilities in a generic way and write code that is more secure, more reliable, and of higher quality. So, this is something which is kind of a defense in depth approach where we are assisting the development community and the operations community to write good code as well as the testing community as well. So, this is something which we can integrate into our DevOps process. Then, during the build phase, what we do, what we can do is we can introduce the secrets check. So what happens is this is a known thing in the industry. So with different developers as well as the operations team members, it has happened many times that in the config file or in the application code itself, many secrets are left committed into the code. And in some cases, it has happened that the repos were public and it has been used by outside hackers to log into the applications and do malicious things. So, in order to avoid such things from happening, we can introduce the secret check, which is automated check for any regex based identification it is. So, it identifies any secrets which lie in the code in plain text and it stops the build from proceeding further. And it will be a validation that the code is not correct in its current form and the developer should go and fix these issues or the infra team should go and fix these issues. This is another check that we can introduce into the process. Second, or the third thing that we can introduce is something which is known as SCA. So the full form of for this is source composition analysis. So what the purpose of, and this is still in the build phase itself. So SCA is something which helps in identifying any vulnerabilities with the third-party libraries. We are using so many libraries in our code. It's not as if we're writing the entire software from scratch. So in order to ensure that those third-party libraries are not like outdated or discarded or older versions which are vulnerable or even the current versions which are vulnerable, in order to identify those vulnerabilities, SCA, source composition analysis, is used. So that's another security practice that we built into the automated DevOps process. The fourth thing that is incorporated, that can be incorporated into the system is SAST. So SAST is, and it is still in the between build and test stage. So SAST is static analysis security testing. So it is kind of a white box approach. When we say white box, it means like we are actually checking the internal structure and workings of the code itself. So we are in the build stage. So we are checking the code quality in a way, and we are checking these, we are performing the checks here. So this thing, this analysis gives you its own set of vulnerabilities that you need to look into. So with this security check-in placed into the system, you have another layer of check-in for the code quality and the vulnerabilities associated with that. Next in the process, you do testing, the automated testing, and then you move the code to the, suppose, your QA environment. And then further, there is another security testing that you can integrate into the system, which is DAST. This is dynamic analysis security testing. It is kind of the black box process. So it works after the application is deployed into a working environment, and then it performs the functional testing on top of that. And it gives you its set of vulnerabilities that you can use for assessing the state of the application. So you see, we are integrating so many layers of security here. This is the fifth one. So in a way, now we are kind of checking the application when it's working in day-to-day behavior, and we are trying to analyze the vulnerabilities associated with that particular application. Further, we deploy the application to further environments. And when we are doing this, we are moving between environments. We are performing the infrastructure security testing as well. So the code that is used to deploy these environments, the testing of that code is done as well, whether that code is as per the requirement or not. That's another layer of security that we add. Infrastructure, or IAC, we can say in short. IAC security testing. This is the sixth kind of layer that we can integrate. There are few more. One is compliance as code. So we can use different tools like inspect and write scripts to check as per the required compliance. So maybe certain companies have to use like PCI DSS, HIPAA compliance, or SOX compliance. So there are different scripts that you can write for these compliance and integrate it as part of your repository and run those compliance checks when your application is deployed. So you can again integrate this as another layer of compliance check or security check. And at the very end, when your application is deployed, you can integrate WAF at the top, which will give you OWASP compliance. So this is a kind of a small view, kind of a bull's high level view on what all components you can add to make your application be more reliable from the security side, and how your entire DevOps process has the integration of security in it. So this in a way gives you an idea of how DevSecOps can be implemented in the current DevOps scenario, what exactly it means, why it's required, and how it helps the company deliver the application fast with more features and with reliable standards as per the security requirements. So I hope you all got an idea why DevSecOps is now becoming a buzzword in the industry along with DevOps, and in a practical way, how we can integrate security into the DevOps process. So let me know in the comment section if you understood with the help of this video what DevSecOps means, and if it did help you engaging the understanding of DevSecOps. And let me know any other feedback that you want to give me. And if you want me to further do a deep dive session on related topics, anyways, I'm planning to bring in more videos related to similar topics in the future. So do like, subscribe, and hit the bell icon so that you get the notifications as soon as I upload the videos. I hope you enjoyed the video. You have a good day. Take care. Thank you. Bye bye.